Okay, I had some questions about regularized training gains, so I'll try and explain it a little bit better. There's two things you want to worry about when you're running MaxEnt. One is the regularization multiplier. This is that factor that defaults to 3, which is usually overfit, depends on your data, but usually overfit. So you usually want to increase that, which will smooth out your response curves. You do want to try different values for this multiplier because it is going to have it's going to change where your response curves work, and it's different based on your data and your species. So that's when you want to try different values till you find the optimum one for your species. Again, increasing the value is going to smooth out your response curves, which will make your performance look worse. Your AUCs will go down, your AICs will go up, but a less overfitting. So that's that trade-off. Also, I should mention the regularization multiplier is also sometimes called the regularization parameter or the beta multiplier. The regularized training gain is different, and I'll talk more about that as well as gain and regularized gain. Okay, so if we go to the original MaxEnt paper, which I recommend reading, whoops, need a PDF here. Okay, so here's the original, and you'll see that there's this equation that looks fairly familiar to us, and this one. And what I've done is I've taken this and modified it a little bit. Should be the same equation, but changed a little bit to be the way we're used to seeing it for AIC, where we have the probability of our sample. So 1 being good, 0 being not so good. If we have a sample at 0 probability, that would be that our model isn't fitting the data. If we have probabilities that are high near our samples, say, yep, we're doing good, good model. Now these can be very small, and if we multiply them together, we end up with these really tiny numbers, so the math doesn't work. So we take the natural log of those and sum instead of multiplying, but the natural log changes the nature of this data. So remember that if you have a 0 for a poor probability, when we take the natural log, that's now going to become a large negative number, and we multiply it times the negative, it's going to be a large positive number. When we have a 1, take the natural log, we're going to get a value near 0. So in other words, what we're looking for here is actually small values. And that's why you'll hear folks talk about minimizing the gain. Okay, now we add those up and then divide by n, so this is also the average log probability of each point. So that's the gain. However, one of the things that trips us up is there's this minus c. Okay, and so C is for uniform, in other words, flat response curves. So we're not really looking to minimize this because that would be 0, which would be uniform. We're actually looking to change this and maximize it so that we get a better model, which is going to make this value smaller, but because we're subtracting the C, it's going to make the overall value bigger. So that's where the gain we want to increase. So average log likelihood minus C. Important thing to remember, we want to increase the gain, even though we're minimizing the log likelihood. Okay. Yeah, just remember, maximum likelihood, minimize log likelihood. Okay, so the problem with the gain is if we just do the gain, we'll get the most complex model possible. We'll fit every single point in our sample data exactly. So to smooth things out, we need to have some type of overfitting correction, which MaxEnt calls regularization. And there's this function where we sum up the regularization multipliers. You can have one or more. You can have one overall, or you can have one for every covariate. And then you have the coefficients for the covariates. Now be warned that people use a little different terminology for the lambdas and the betas, so that's a little confusing in the papers. But this is the idea, is that as your regularization multipliers go up or the number of coefficients go up, this will increase. Okay, so given that, we now have that MaxEnt minimizes these two, and you'll see this in the papers where it minimizes these two guys, okay, the log likelihood, okay, or the negative log likelihood, and then the coefficients, okay. So it tries to have the highest likelihood, take the natural log, lowest, and the smallest number of coefficients. So related to AIC. Now, one of the issues around this is then the regularized gain is we take that whole thing and we subtract c from it. And now, instead of trying to minimize the gain, or in this case the regularized gain because it has this parameter in it, okay, we're trying to maximize this. In effect, you could say that we're trying to get away from C. Let's see how far from C we can get, because C is uniform. Okay, so that would be the best we could get, would be actually the value of C. Okay, and so that's the regularized gain. The regularized training gain is that gain for the training data. Okay, now, one of the interesting things that I had a question about is why, as we increase the regularization multiplier, what's happening to the regulation training gain? And you would expect, as you increase the regularization multiplier, I would expect that it wouldn't have any effect on the unregularized training gain, because there's two that show up in MaxEnt, because that would just be the regularized training gain without the regularization, right? So I ran a little test, and I changed the regularization multiplier, and I did not expect this to have an effect on the unregulated training gain, but it did. In fact, they track each other pretty well. So I'm not exactly sure what's going on between these two, and that would be an interesting exercise to try and research it, but I found very little describing the regularized training gain in detail. In other words, specifically what the user interface, the values it was creating. I did go ahead and get the code. I have it, and it looks like, as you notice, these values are higher. Okay, and in the code, the unregularized training gain actually has the regularization values added to it, and this one does not. So the names don't make sense to me, but the graphs do. All right, so I hope that helps. But again, coming back for the assignment, it's really the regularized training gain and the regularization multiplier you want to worry about. And here we're trying to maximize this within the range that's given in the output. And this one you're modifying to get the response curves look the way you want.